going to be grading papers, and we're also going to be checking through the LeChatelier logic. So to check out LeChatelier logic, we need to use some kind of a method which I've come up with that I've found to be quite successful. So we're testing out heat now. On the left side of the screen, you see the actual problems that we have out of the Zoomed-All textbook, and I have a better picture of that in the homework pages that I've had over the last week. But right now, we're just going to check out student by student, problem by problem, and see if we can get this understood. So our first problem has to do with ammonium carbonate, and we got NH4 and CO3, and I believe the ammonium, there's two of those, yes? Okay, so we got two of those, and the ammonium carbonate is a solid. Okay, so this guy's going to be a solid, and we're going to go back and forth, and we're going to create ammonia, NH3, and this is not going to be a balanced equation because I don't care about the balancing because it really has no effect on the LeChatelier shift for heat. But for other things, you have to have that in so you can make the equilibrium expression, right? Okay, so we got ammonia, and we got carbon dioxide, CO2, and we have, what's the last one? Water. Okay, and this is all, on the right side is all gases. So they will respond in a LeChatelier equilibrium. How about the solid? Is that going to matter? No. Absolutely not. Because solids and what else? Liquids. Good. Solids and liquids don't count. Now, the next thing we want to do is we want to find out where is the heat. So, Lewis, would you tell us where the heat is? First of all, is it exo or endo? Let's get that down.
It's endo.
Okay, it tells us right in the problem that is endo. Now, endo means the heat is on which side?
The left.
The left. Okay, so the heat is going to be over here, and it acts just like any reactant. Okay, so if I use it up, I'm going to be going off to the right. If I am going to produce heat, I have to shift to the left if I'm LeChatelier. Okay, but we're going to figure out the stresses first. So, Lewis, what's our first stress? Or what is the stress? Okay, at a lower temperature. So we're going to do a down arrow for temp. And why don't we go ahead and make this just a single pane? I don't think the left pane is really going to help us a lot. There we go, and we can see everything a lot better. Okay, what does LeChat want to do? He wants to raise it. So we've got LeChat wanting to raise the temperature, and how in the world is he going to raise the temperature? Is he going to make heat or take heat away? He wants to raise the temperature. He's going to add heat, okay? How is he going to add heat? Is he going to shift, is he looking at going to the same side as the heat or opposite side of the heat? Same side, okay, that's going to make more heat. So, same side, and the same side is which side? Yes, the left, and that's the shift. And it's just that easy, folks. Just that easy. So, would you grade that, but don't include it in the score? Okay, because that's not what we're grading right now. We want to grade the 5 problems that were actually the homework. So, Edward, how about it? Yeah, yeah. Okay, so we're doing number 38, and for problem number 38, let's get this eraser a little bigger and get rid of this stuff. Okay, and let's just use the back and forth arrows. And first of all, let's establish, is this thing exo or endo, and how do you know? I'm talking to Edward. Yes. because it says it, right? Okay, so endo is what I'm going to put here just to give us an idea of where the heat is. If it is endo, which side is the heat on? Look at your notes. Do you have your notes? Yes. Okay, so heat is going to act like a reactant. All right, is that all together? Oh, good. All right, so if this guy's endo, now that we have the heat on the right side, it's actually the left side, but it's the correct side is the way I should have said it. So with the heat on the correct side, what is the stress? Edward, you're going to solve the whole problem here. So what is the stress in number 38? Okay, we're going to put the temp up. Raise the temp, and what does LeChat want to do? Decrease it. Okay. And to decrease, he's got to remove heat. Good. Remove heat. Okay. Now, on this side of the equation, this is a whole different equation, but I want to talk about breaking and making bonds. Because when we do this, and this, and we make a chemical bond, we store energy. If we store energy, we are doing an endothermic thing. Okay, there is a bond between those guys. When I pull them apart, that takes energy. The energy is released. The energy that was in the bond is released as thermal energy, and the temperature goes up. So what happens when I put them together? I'm taking the heat and I'm changing it to bond energy. And so right here is where the energy is stored, and that took heat out of the environment. So when you feel the beaker and you have an endothermic reaction going on, it's going to get cold. That's because it was making the products over here. When I do this, I am releasing heat, and that's an exothermic reaction that will produce heat. When you put your hands around the beaker, you are going to find that beaker getting hot, or warmer anyway. And that's the sign of an exothermic reaction. So when we remove heat, okay, removing heat means we're making bonds. Okay, so if we remove heat, which way do we have to go? Same or opposite? Opposite, yay. Opposite to the heat. That uses the heat up. And now, Edward, which side is the heat on? Okay, what is the opposite side?
I think you're right.
No, you're correct. You said it right. The heat is on the left. So which side is the shift going to be to if it's opposite? What's opposite of left? All right, there you go. See, the one just before, okay, sorry about that. So the one before, this last guy, no, I don't want to delete. Right here, this guy shifted left because it was same, and the last reaction was what? Exo or endo? It was endo. Okay, so we had two endothermic reactions. When we added heat with an endothermic reaction, the heat is on the left, and the same side is the left. And that's why the shift was the left. Here, we're going to the opposite side. Since the heat is on the left, the opposite side is the right, and that's why this is a right-hand shift. How's that work? Huh? That making sense? All right, let's go on. We're going to do 39. And in 39, that's going to Todovik. So Todovik, tell us what do we have here, an endo or an exo? You should all have your textbooks open to 539. And this is the Zoomdall text, not the CMC that you have at home. Huh? This is exothermic. It says it's exothermic. Okay? So that's nice. So we have an exo. Now, Tadevik, do we leave the heat on the left? This guy's exo. Which side should the heat be on? According to the rules that I just had you copy down, we haven't shown that yet on the video. This is what everybody copied before we started. Okay, so which side is the heat on? The right side. Okay, now that we've established where the heat is, now we need to go and find out what the stress is. What? Raise the temperature. Okay? Is that what it says? What are the actual words it uses there for 39? Increase temperature. That works. Okay, what does LeChat want to do? Always does the opposite, doesn't he? He always wants to do the opposite. And to decrease the temperature, does he add or remove heat? He removes. He certainly does, just like in the last one. And this is going to be an interesting result. REMO, yowie. Trying to do too many things at one time. Remove heat. Okay. And is that same or opposite? It's opposite. Yes, it is opposite. So, OPPOSITE, opposite. Okay, now, let's look. Heat's on the right. So, opposite, yes. And because this is opposite, we now have established that this is what kind of shift, left or right? Left. Okay. Okay. So we got left now. LEFT, thank you. All right, looky here. We had the same LeChat reaction, but we had a different shift. Tadevik, why? LeChat did the same thing, or did he? You remember what this reaction was, exo or endo? Huh? See, we had temp up, temp down, remove, heat, opposite, remove, heat, opposite, but the reaction moved it to the left. Why was that? The heat was over here. It was an endothermic reaction, right? And because the heat was over here, opposite is a different direction for the shift. That's why this chart works so well, because it keeps your head on straight. It really does. Okay, let's go with 40. That'll go with Robert. Okay, Robert, are you ready? Yeah. Tell us, do we have exo or endo? Endo, huh? Okay, let's try it. Endo. All right. So, do we leave the heat where it is or change it? No, there's no shift here. Where is the heat? Where's the heat? It's endo. Where are your notes? Do you have them? Okay, tell me where the heat is for an endothermic reaction. You've got to get the heat on the correct side or you can't do the problem. What? It is because it's endo. Okay. Now, because this is endo, and we're talking about number 40 on page 543 of the Zoomdall, what's the stress going to be? Increasing temperature. Okay? And if the stress is a temperature increase, what does LeChat want to do? You bet he does. Okay, temp down. And now, what does he do to get the temp down? Does he want to remove heat or add heat? He wants to add heat, and that's going to make the temperature go down. Wants to take out heat, like the refrigerator does. Doesn't a refrigerator take the heat out?
Yes.
Yeah. And where's the heat go?
Outside.
To the back of the refrigerator, huh? Yeah, absolutely. Okay, so we're going to remove heat again. Wow, we got this remove heat thing down, huh? And how do we remove heat? Same or opposite? Yeah, we remove it by opposite. Now, with the heat on the left, what is opposite? Okay, and where's the shift? Yes, indeed. Isn't that fun? Look, all three of these, the temp, are, what LeChat does. Oh, this one is different. Okay, but when the temp goes up, whoa, let's get that fixed. Okay, here. Go back. Come on. Here. There we go. Get it out of the middle there. Okay, when the heat's going up and the temp, or when the temp is going up and LeChat wants to put it down, it's not necessarily going to determine whether it's a right or left shift. It's whether we're removing heat or adding heat. And it's same or opposite, okay? So with the heat on the left, opposite means the right. Okay, that's the endothermic reaction where we have to remove heat because that's what LeChat wants to do. Okay? All right, we're working on page 41. Our first thing is going to be to decide if we have an exo or an endo, or whether we have heat on the left or right. Okay, so what do we have in this particular problem? What? Endothermic. Now, why do you think this is endo? Does it say absorb? It does, doesn't it? So, absorbing means that heat has to be on the left because it's like a reaction. So, heat is going to be over here. Is that all together? Yes, it is. Good. Okay, so what's the stress? Temperature increase, huh? Okay, does the sun provide a temperature increase?
Yes.
Always. If it's getting through the clouds, okay, it will always provide a temperature increase. And that happens because it's giving radiant energy, which we call heat. Now, heat doesn't make the temperature what it is. Temperature is a matter of how much total heat there is. More heat, temperature, up or down? Up. Up. Okay, so when the sun goes away at night, what happens to the temperature? It goes down. You bet. It radiates out. Boy, you got a lot of cleanup done back there, huh? Okay, Yura. We got temp up. LeChat wants. Good. We're going to bring the temperature down. Okay. And what does he do to get the temperature down? Does he use heat or does he make heat? Use it. You got to use it to get rid of it. Uses heat. And when he uses heat, after he uses the heat, is that going to mean he has to enable the, in order to use it, there we go, got it out. In order to use heat, does he have to go to the same or opposite side of heat? Opposite indeed. Bye-bye. And now, if he's using the heat, and we're trying to figure out what the LeChat thing is, when he goes opposite, which side is heat on?
The opposite.
No, which side is the heat on? Left. Okay. And so, opposite of left is?
Right.
And that's the shift. So, that's what plants do, folks. They are involved in an endothermic reaction, absorbing the energy from the sun. You remember that chart I made for you with the sun in the top left corner and you in the bottom right? Yeah, that's what's going on. It's the energy cycle. Okay? All energy comes from the sun. If the sun goes away, so does all of our energy. All of it. And fast. Fast.
Like lights and stuff.
Yes. Lights, heaters, you name it. It all goes away because you won't make any more energy anywhere without the sun. Interesting, huh? You can change the energy around. You can take the energy that's in wood and you can burn it, but once that's gone, it's over. Ouch. Sounds kind of important, huh? Yeah. Okay, let's do 42. Now, 42, you have to think as a manufacturer. And we're going to have a chance to deal with kilojoules on this guy. So let's see how this actually works. And we're going to go to Gavin. You get to do this one. Okay, Gavin, you are a manufacturer. You are taking nitrogen and hydrogen, and you are going to try to make ammonia, and you want to make a profit. There's our ammonia. Okay, Gavin? Now, we have to figure out whether we need to do what? An endo or exo type of reaction. What is this? How do you know? Okay, positive kilojoules. What is the positive number? What? 92 kilojoules. Okay, when this reaction goes on, it releases, or it takes in 92 kilojoules, which means the system itself, the chemicals, are getting energy. And they're storing it as chemical bonds, like I showed you in this slide. Okay, this slide, store it into chemical bond. Endothermic, what I just did. Exothermic is taking them apart and releasing the chemical bond energy as heat. It's all energy, just different forms of heat. Okay? Now, since we know that the kilojoules are negative, or positive, I'm sorry, heat's going to be over here. And we call this what kind of reaction? Endo or exo? Endo. Good. Okay. So, what's going to happen with the temperature? Okay, but we've got to do this both ways.
Then he wants to lower it.
Okay. Now, because he's going to lower the temperature, whoops, oh well, different color. All right, so are we going to use heat to make it go down? Yeah. Okay, so we're going to use heat, and if we use heat, is that same or opposite? Yes. And since heat is on the left, what is opposite? And that's the shift. Now, this is very interesting, folks. Do you want to do this in Alaska? You want to make money now. Do you want to have your manufacturing plant in Alaska or in Panama?
Panama.
Why do you want it? What's going to drive this reaction more to the right? You're trying to make ammonia. Okay, if I remove heat, LeChat wants to make heat. He's got to go to the left to make heat. Is that going to give us more ammonia going left?
Yes.
Come on, ammonia is taken apart when you go left. You're making more ammonia when you go right. add heat, drives it to the right. That's it, folks. Hope this helps.
Save it.